Due to both its shape and geographical position, the Gulf of Finland is a very vulnerable maritime area. Navigation in the narrow gulf is a demanding task, due to its long, relatively shallow and broken archipelagic coastline. In addition to the year-round requirements made on vessels using the fairway, winter brings its own increased demands. In 1995, about 22 million tons of oil were transported through the Gulf of Finland by sea traffic. In 1997, the amount was about 30 million tons, and in the year 2000, more than 40 million. Other sea traffic has also increased rapidly, bringing with it even faster passenger vessels that cross the Gulf of Finland throughout the year, cutting the heavy shipping traffic fairways at several points. Oil traffic, according to planning, will double that of the present due to several new ports that Russia is building in the eastern end of the Gulf. Similar forecasts are made for other maritime shipping. By the year 2005, it is expected that about 80 million tons of oil will be carried through the Gulf of Finland. By 2010, it is estimated that the total cargo transported in the Gulf of Finland will be about 160 million tons, with more than half of this being oil.
We have to take into account in order to avoid big accidents, to keep the quality of the traffic so high as possible and take all necessary precautionary measures like escort towing and double hull tankers and things like that. But in spite of that, we have to prepare to take care of real accident in any case. It means we have to have good equipment and good readiness to cope with the real situation in order to prevent those accidents growing big disasters.
The environmental risk posed by such an increase in traffic presupposes a proportionate increase in the development of preventive surveillance and safety systems. In particular, the unrestrained increasing quantity of oil cargo requires investment in damage control technology by the coastal states. A mutual definition of the fairways and clear traffic regulations also form part of safety procedures. The establishment of a state of preparedness for oil combating and its maintenance is the responsibility of all the coastal states of the Gulf of Finland.
The cooperation between the coastal states of the Gulf of Finland has been very good one. We have been doing joint exercises every year, and we have also assisted each other in real cases. We have exchange of information about the new technology and developing of that. And besides of that, we need in future, of course, new equipment and new better tools to cope with the situation. But the basic is very fine.
I think sometimes this cooperation is better than cooperation between organizations in Russia. Sometimes I think so, because we are very close with Finnish Environment Institute. We contact all the time. Our working group work constantly. We meet at every exercise and have 2,400 hours contact with representative of Finnish Environment Institute concerning the situation in our areas, in Finnish area and in Russian area.
Cooperation in oil recovery takes place in the form of regular exercises. In Contacts Beyond Borders, in spring 2002, Russia and Finland arranged joint oil combating exercises in Russian waters in order to test cooperation and the states of preparedness. In these exercises, the Finnish Navy provided the oil combating vessels Halli from the Archipelago Defence Area and the Hylja from the Gulf of Finland Marine Defence Area. The Finnish Maritime Administration provided the oil combating and fairway maintenance vessel Linja from the Archipelago area. From Russia, the oil combating and sea rescue vessel Yasny took part together with the Russian icebreaker. The exercise was realized at the instigation of Russia and under its supervision. The task of the Finnish Environment Institute Syke is to direct and develop methods for environmental damage control in Finland and to be on standby to respond to oil and other special accidents, including oil combating duties in Finnish waters. In the event of an accident in Finnish waters, Suke directs the recovery and damage control and is assisted, if necessary, by the armed forces, the border guards and the maritime administration, who supply personnel, oil combating vessels and other materials. Together with the frontier guard, Suke keeps a watch on deliberate discharges into the sea, such as bilge oil and other waste. Suke develops methods for removing oil from wrecks and other damaged vessels. If necessary, Suke will organize containment and oil removal projects for dangerous wrecks. Suke also acquires oil combating equipment and maintains a state of preparedness, as well as developing technical methods and equipment. In this program, we shall look at the surveillance and state of preparedness for oil combating operations in the Gulf of Finland. We shall show oil recovery methods suitable for winter conditions and study the latest oil combating equipment. At the moment, surveillance of the Gulf of Finland is carried out by air, sea and radar systems of its bordering states. Finland carries out its own air surveillance with Dornier 228 observation aircraft equipped with detection instrumentation for environmental accidents. The crew gets a real-time picture of our maritime area and of any possible non-natural materials in the sea. The aircraft simultaneously takes care of both frontier and environmental surveillance. The Finnish surveillance area is that contained by the Finnish fishing limits. The greater part of the discharges detected from our area are those occurring outside Finnish territorial waters. In the year 2001, observation aircraft detected a total of 107 oil discharges, of which 23 were inside Finnish territorial waters. The infrared cameras of the observation aircraft easily pinpoint the thickest part of the oil slick and are able to direct the containment and recovery vessels so that the oil is removed as quickly and effectively as possible before it reaches the shores. As part of the state's internal security system, the Finnish Coast Guard Authority for the Gulf of Finland is responsible for frontier surveillance and frontier controls within its area, as well as for sea rescue operations carried out together with other official and voluntary organizations. The Finnish Coast Guard Authority for the Gulf of Finland is one of 3 branches of the Coast Guard Authority. It consists of 3 Coast Guard ships, 25 Coast Guard boats and 2 hovercraft. The Coast Guard stations and ships take care of Coast Guard-related duties carried out at sea. The Coast Guard ships are also equipped for carrying out duties underwater. The ROV submersible works underwater by remote control and is able to illuminate and film desired details. Vessels patrolling Finnish territorial waters or within the Finnish fishing zone for both Coast Guard and sea rescue operations observe the maritime situation in cooperation with the Finnish Environment Institute. Fixed surveillance based on radar and observation form the basis of the Finnish coastal surveillance system. The heart of the state's picture of the maritime situation is based on fixed Fika radio stations erected along the coastline. These stations have a range of 50 to 70 kilometers and can automatically follow 26 different points at the same time. The fixed radar stations are placed along the coastline in such a way that, together with those of the Coast Guard and Maritime Authority, they comprise a sufficiently broad network. Self-identification systems installed in vessels, together with optronic and underwater surveillance systems, complement the radar coverage and partly replace human observations. The importance of radar surveillance is emphasized in bad weather conditions when human observations are limited. On the larger vessels, the radar equipment is especially versatile and can be used for both air and sea observations up to a 100-kilometer radius, with an accuracy of under 20 meters. The main fairway in the Gulf of Finland archipelago, in an east-west direction, is a 15-meter lane. It is well marked and there are sufficient restrictions on traffic through the ice. Traffic is observed by covered, fixed radar stations along the whole of the fairway, and a pilot is obligatory. In addition, large tankers may also have the help of tugs. Maritime safety is improved by lanes to which the ships adhere. Vessels sailing in a one-way lane follow each other continuously. The purpose of the projected VTMIS, or Vessel Traffic Management and Information Service, is to improve the safety of sea traffic, and it is believed that this will reduce the danger of ship collisions by an estimated 75 to 80%. Extremely precise navigation is required on the passenger ship route between Helsinki and Tallinn, which cuts across the east-west tanker route. Due to the demanding conditions placed on traffic in the Gulf of Finland, the ships are usually new and the navigational systems are modern. Tankers are usually double-hulled, so that in the case of an accident, damage to the environment is usually reduced. Single-hulled oil tankers will be phased out between the years 2003 and 2017. For example, during the winter, only double-hulled tankers are permitted to enter the new oil terminal in Primorsk. These are usually assisted in by 2 icebreakers. The present rate of development indicates a future growth in the size of ships, but without a subsequent proportional rise in the number of accidents.
The risk of oil spillages will grow up according to the growth of the traffic. It's mainly depending amount of journeys, the movements of the ships. Of course, a very important factor is of course the quality of the transport. It is more depending on quality than amount of the trips.
The most important factor in preventing the destruction of the environment is to be in a state of readiness, whereby one is able to remove oil spillages effectively, quickly and carefully, in all seasons, and so prevent it reaching the shores. Well-organized oil combating operations, working in harmony, is the common goal of the states of the Gulf of Finland. Cooperation in exercises and development plays its part in achieving this goal.
The most important thing in oil combating is timing. Timing is everything. And if something could be added, it is a little bit creativity helps. You have to have methods you have used earlier. You have to have different kind of tools in your tool packet and make some kind of selection of them according to the real situation. The purpose of this exercise is to demonstrate the available technique in oil combating in ice conditions. Finnish Russian units are doing this exercise together. It is joint exercise and the Estonian authorities are also represented as observers.
Participant of this exercise was from Russian side. One salvage tug, Yasny, from Marine Pollution Control and Salvage Administration of Russian Federation, and assistant an icebreaker of Marine Administration of Port St. Petersburg.
We will in practice demonstrate the use of those equipment and just to look how it works.
For the purposes of the exercise, the oil combating vessel Halli is fitted with a bow-mounted ice cleaner, which 2 car cranes on the deck move to the bows when in the exercise area. The Hylia was fitted with an oil recovery bucket, that is, a piece of equipment that is fitted to the vessel's bow crane. The Linja was fitted with the Finnish Environment Institute's newest invention, the Ice Vibrator, which separates oil from ice. The Russian vessels also had special equipment for collecting oil in icy conditions. When notice of an oil disaster in icy waters is received, the Finnish-made ice cleaner is lifted from its storage place onto the deck of the oil-combating vessel Halli. The ice cleaner was manufactured at the beginning of the 1990s and is the only one of its kind in the world. It was developed especially for recovering oil mixed with ice. Since the ice cleaner weighs 25 tons, it requires 2 large mobile cranes. The mobile cranes accompany the combating task, since they are needed to place the ice cleaner into position at the scene of the accident. The combating vessel can move quickly to the scene of the accident since the ice cleaner is not in the water, slowing its progress. At the scene of the accident, the ice cleaner is lifted to the side of the ship and floated round to the bow of the Halli, where it is attached. The whole operation takes about 4 hours to complete. The necessary power to drive the equipment comes from the Halli's pump and hydraulic systems. As soon as the ice cleaner is attached and connected to the vessel systems, the oil collection can begin. The collection of the oil takes place when the Halli sails over the oily ice, and moving brush ropes under the cleaner separate the oil from the oncoming pieces of ice. The oil adheres to the ropes and is carried with them into the interior of the cleaner. The oil is wiped from the brush belt into the cleaner's collection tank, from where it is sucked into the ship's storage tank. The ice is washed with water throughout the whole of the collection. The water used for washing is sprayed in front of the brush so that the oil adhering to the ice is better removed. The ice cleaner collects oil for almost the whole of its width, or 6 meters. The speed of the vessel can be 1 to 2 knots. 1,400 cubic meters of oil can be collected continuously, that is, until the Halli's storage tanks are full. The storage tank must then be emptied into that of another vessel or to a shore-based tank. The ice cleaner has been tested many times in icy conditions, and its operation is proven. Happily, it has not yet been necessary to test it in actual disaster conditions. The Ice Vibrator is a new step forward in oil combating. It has been developed for mounting on different ships, for example as a piece of fixed equipment. The equipment is fixed to the side of the vessel at the start of a recovery operation, and is raised and lowered hydraulically as required. The vessel can move to the accident area at normal speed, and the ice vibrator is lowered to collect the oil only when it reaches the site of the accident.
Tässä jäässä tapahtuvassa öljyntorjunnassa on se tietysti se hyvä puoli, että öljy ei siellä jääkentässä hirveän nopeasti leviä. Et siihen on aikaa paremmin kuin avovedessä tapahtuvassa öljyntorjuntatilanteessa.
The operating principle of this Finnish innovation is as follows. The equipment is lowered to the level of the ice and is locked to the side of the vessel. The structure and thickness of the ice determines the speed during the oil collection. The equipment fitted to the linea is a prototype and enables testing of different inclinations of the bar screen. The distance between the bars of the screen is 20 millimeters, which defines the size of the ice passing through it. The screen is vibrated hydraulically at frequencies that can be varied. In this manner, the oil separates from the ice and passes through the screen into the interior of the equipment. From there, the oil is conveyed to the collection basin, from which the brush belt carries the ice which has passed through, together with the oil for separation. The oil adheres to the bristles of the brush belt, and the particles of ice caught between the bristles rise to the top of the belt where they are separated. An Archimedean screw then conveys the ice back into the sea. The oil remaining on the brush belt is physically wiped off the bristles and drains into the storage tanks. The collection capacity of the linea is 79 cubic meters, after which its tanks must be emptied to another vessel or to a shore-based tank.
Kapasiteetti voidaan määritellä sillä tavalla, että pyyhkäisyleveys on puolet laivan leveydestä. Eli jos tällä ajetaan meressä ja laiva on 10 metriä leveä, niin se on noin 5 metrin kaistaleen sitä merta puhdistaa. No me saatiin 3 ajonopeutta ja nähtiin, että solmun nopeudella sekä tämän laivan keula että tämä kalteva pinta työntää jäitä edellään. 2 solmun nopeudella lähtee menemään tavara tonne laitteen puimakoneosaan ja 3 solmun nopeudella oikein kovastikin hyvin menee sinne.
The possibilities of ice vibration on a large scale are being examined, and it is believed that the system belongs to standard oil combating equipment, including a new generation of icebreakers. The oil recovery bucket is an oil recovery device developed by the Finnish Environment Institute that is especially suited for both land and sea use in all seasons. The operational principle of the oil recovery bucket is simple and it is easy to mount on various lifting apparatus. The collection of the oil is carried out when the slowly rotating brush collects the oil and its fibers, from where it is wiped off to the bottom of the bucket. A suction device is installed in the bucket. This sucks up the oil that has gathered in the bucket and transfers it to a storage tank, either in a ship or on land. The ice recovery bucket can just as easily turn and clean oily stones on a beach or separate oil from ice in a winter sea. Due to its small size, the capacity of the oil recovery bucket is limited, and at present it is used for smallish operations or as a support for the ice cleaner and ice vibrator. The oil recovery bucket is a necessary first aid device for situating on every coastal county beach for combating small-scale oil damage. In addition to the previous methods mentioned, one can also use the rope mop. This method relies on a physical property of oil which allows it to cling to the strands of the mop. The rope mop equipment is moved by the ship's crane. The system also works in icy conditions. The rope mops are lowered into the oily water and are slowly moved by a motor through the collection part of the equipment. Oil clings to the strands of the rope mop and is conveyed to the collection apparatus. Here the oil is squeezed out under pressure and sucked into the ship's collection tanks. Several such rope mop systems are manufactured outside Finland and work best in calm conditions where the rope strands cannot become tangled and slow down the collection process. The system works best in conjunction with heavier collection equipment or in cases of minor oil spills.
Exercise was quite successful. We were able to do everything we decided to do in advance, and we were able to find out some small betterments to those equipments, and well, I'm quite satisfied.
For our side, the next task is modernization of our equipment, because equipment we have got now, it is equipment of 80s. It is not equipment of our century. And now we try to change some types of equipment for modern. And it will be the task for next 2 years.
The future in oil combating in the Gulf of Finland seems to be a little bit frightening. But it is also promising in that respect that we have having new equipment, and we have also developing our ability for different kind of conditions, and in that respect we have to look forward to it.
From the point of view of the development of the state of preparedness for oil combating in maritime environmental accidents, the greatest emphasis must continue to be placed on the cleaning up operations after oil accidents, in view of the frequency of maritime disasters. When the oil combating vessels are renewed, they should be built bigger, but the number of vessels does not need to be increased significantly. An exception in this respect would be in the eastern part of the Gulf of Finland, where, for obvious reasons, a combating vessel is needed. The ability to deal with chemical spills in the Gulf of Finland is a constant need that can be taken into account when new vessels are equipped. The movement of large tankers in the eastern part of the Gulf of Finland presupposes that the fairway opened by the icebreakers will be up to twice as wide as the icebreakers presently in use. Keeping the fairway open and moving safely within it will mean a continuous icebreaking operation in the depth of winter. A new type of icebreaker has been designed in Finland to solve the problems of clearing wide fairways. This solution has been given the working name of the oblique, due to its special working angle.
Icebreaker development is something we have been dealing with the long-term side. And already 10 years ago, we were the initiators of a new propulsion system, the so-called electric bodied drive system, And this gives the excellent opportunity that the full power of the vessel can be directed to any direction. And making benefit of this, so we recognize that there will be the need of assistance for big tankers in the Gulf of Finland, which will be entering the new Primorsk terminal. And this plan was published already many years ago, and we could foresee that there will be the need for better economy in assisting the tankers. And traditionally, this size of tanker, which is more than 40 meters in breadth, requires 2 major icebreakers to make a channel. The basic idea of this oblique icebreaker is that, in fact, you turn the side of the vessel to make the ice breaking, so that the full length of a smaller ship can be utilized to make the ice breaking. And with this idea, we are able to achieve with one single vessel a channel which is more than 40 meters in breadth. In order to steer the vessel in this direction, you need three propellers. And that leads to the fact that the vessel is oblique and very special in form. The other side is like an ice-breaking bow, in fact a very wide bow, and the other side is like traditional straight ship side.
In addition to its own highly efficient ice-breaking properties, the oblique can be equipped with oil collection apparatus for both summer and winter conditions.
So far this oil collection from ice conditions has not been possible. Finnish Environment Institute has developed now a new device, a kind of vibrator, which is able to clean the ice pieces. But the problem is that this unit is still very narrow. But installing this unit into the straight side of this oblique vessel, you can then steer the vessel to approach the ice in such an angle that the side in fact creates a plow that collects all the ice pieces into the vibrator. So that's why this is many times more efficient than a traditional vessel in collecting the ice into the vibrator. We have made the model tests already, and this also show that this is working in an excellent way also in open water. And then you are also using the straight side to collect the oil, but in addition you are able to put some mechanical plow type of device to the other side, so it's really an efficient collector.
The construction enables oil to be collected in considerably harsher weather conditions than with traditional solutions, because the current flexible collection booms attached to the sides are not needed. The side of the hull of the oblique directs the oil it encounters to an oil collecting port at the stern, from where it is then transferred to the voluminous internal tanks permitted by the special shape of the hull.
It's like a large tugboat. We are talking about a length of 50 meters and a width of some 20 meters. So this is much more cost efficient than using of two tailor-made. In fact, 3 tailor-made ships, because you are replacing 2 icebreakers and 1 oil combating vessel in one single unit.
The Finnish Environment Institute, Syke, took part in the development of the oblique oil collection system and is now participating in planning the oil combating equipment. The oblique would be a notable addition to the oil combating capacity of the Gulf of Finland and would help to preserve the present state of the environment. The Finnish Environment Institute has verified that the new oblique would be admirably suited for towing giant tankers into port. It means that this invention has a considerable international potential, especially now that large oil concerns are operating in iced-in offshore sites.